after y'all. So this lecture, I mean, it's really just going to be a review of what y'all already learned in case it didn't stick. Or if you already kind of understand it, you can work on your homework or lab. And then I'm going to just be going around helping y'all with the homework in the lab. I'm not introducing nothing new today. Questions before we start? So like I say, I'm going to do a recap. I'm going to recap functions in general because you need that for your lab. I'm going to do a recap of string functions. I'm going to give you some tips for your lab in case you kind of like falling behind, you don't really, it's not sticking. And then I'm going to remind you of your homework and what you need to do when you leave here because I don't see you again until Tuesday. So remember, a function is a set of instructions that helps you do one specific job. So just like you had make a peanut butter and jelly, we had 4 or 5 individual steps within that as a whole does one big job. That's all a function is. How do we identify a function? You always have your opening parentheses and your closing parentheses. That means you call it a function or you creating a function. And main is the first function that we learn. Every function after that will pretty much be a function that we create ourselves and that we use ourselves. So substring, at, all of those functions we were doing in the lab, those are functions too. Again, if you missed this the first time it was shown, there are 3 functions being called in this code. We know what those functions are because the open and the closing parentheses, right? So going from line 1, going down, line 4 does not count as calling a function because we're creating the function. We know that because the opening curly brace right here and the closing curly brace right here. That means we're adding the steps for this function. We haven't called it because it doesn't even exist yet. We created it. So on line 5 is where we end up calling our first function. It's called foo. We know that because it has a name, just like a variable has a name, and then it has its parentheses. Questions on that? Somebody come on that side. Yep. So, she said, what do the parentheses mean? Why we need that? We'll get to a point, or even in your lab, right? You saw string name inside of here, like you had question, let's say question 0. It had string name on the inside of those parentheses. At a deeper level, functions have something called inputs or parameters. And so even think about the substring function we've been using or the at function. You put a number on the inside. C++ uses that inside the function. It's a little mysterious and we're not really getting into functions on a deep level yet. I only introduced it because we're using string functions, and so in order to understand what a string function is, you kind of have to know what a function is. So don't too much worry about the open and closing parentheses yet, but the fact that we have them means that we're calling a function and not using a variable. So if you don't see those parentheses, that means variable. If you see the parentheses, that means function. Questions? The next one being called is bar. We know that similarly because we have the opening parentheses and the closing parentheses. Same as line 5. And lastly, we have bars. Same exact thing. We have the open parentheses and the closing parentheses. All 3 of these functions are being called in different ways, right? This one we're calling and we're returning a value and we're storing the value. This one returns a value, but we're just printing it. We never stored it. We never stored that value in any variable. We just got the return value and we printed it. The last one would be your example of like a void function, because all it does is get called, and it never stores or prints anything. It just gets called. So it does some instructions, and that's it. Questions on the three contexts in which you can like call a function. So talking about bands right on the blue line. So bands is a function that gets called. The thing with this is we never store the return value anywhere. Like we just called the function plainly and that was it. So we implied that it doesn't return anything. So it must be a void function. Otherwise we would have stored it somewhere. Okay. So, okay, yeah, they're two different meanings. Yeah. Okay, I got you. Yeah. Exactly.
So, here for a call regarding this, do you have someone put that up?
Thank you. Did anybody mistake char and void for the same thing? Since I said I would accept both answers on the quiz, does anybody think I did the same thing? So now going back to the example we saw earlier this week or last week. Oh, what's up? Char and void. Yeah, what's the difference between char and void? Anybody know what a char is? Again, you have your PB&J steps. We already seen these. This is what you're going to see in your lab. You're going to see a whole bunch of void. Void means no return statement goes on the inside. Void means we're going to do a whole bunch of steps, and that's it. We're not returning anything. This is how I will call my void function. I will call it with the name, open and closing parentheses, and that's it. I won't assign the result to any variable because it doesn't return anything because it's void. It has no return type. On the other hand, we have functions that do return stuff, right? Let's say a mathematical function. We compute and then we return. So looking at line 4 on the right hand side, right? Let's say add, right? We know to add you need at least two values. On line 5 and 6, I create those two values. I have 10 and I have 3. Normally, let's say, just following on. Let's say I have 10 and 3. On line 7, I add those together. I meant to put int right here. I can actually... So boom, I add them together and I store the result in a variable called sum. That's not enough. Now I need to return that value because somebody called this function expecting a response. They want to add two values and they want the sum back. So that's why I return the sum. Does that make sense? Did I lose somebody? So here in line 11 through 14, when I actually call that function, I call add, and remember, add is returning the sum of x and y. So I create a variable to hold that value, which would be what? 13. Who did I lose? Question. Yep, exactly. So lines 4 through 9, I create the function. You know I'm creating it because the blue squiggly lines, right? That's me creating it. On line 12 is where I use it. Before I can even use it, I have to create it, right? Otherwise, if I say, hey, add C++, add, it won't know what add means. So I need to specify the instructions. Just like I have instructions over here, 1, 2, 3, 4. These are the instructions for this function. Every function has its own instructions to do whatever job you need to be done at the time. Questions? Other questions? Cool. So back to your string functions. These are the main 4. One of them is not actually a function, it's more of a utility, which is concatenation, and that's just joining strings together with what? The plus. The 3 functions after that, substring and at are similar in a way. Substring gives us a portion of a string. The at function gives us one character from a string. We know when we call the at function, it returns a char, not a string. To your question about char, substring gives us a series of characters, so it returns a string, whereas at returns only one character, so it's a char. And I'm going to show the examples again. Concatenation, in the green we have the plus symbols. That's how we join the strings together. But we also know if we're joining raw values together that don't have variables, we need to wrap it in the purple, which is the string function. So in line 2, we want to join PB and J together. C++ does not know how to do that yet. So I have to add the string function around the first value. After I do that, I can join as many strings as I want together after it. Same thing on line 3. I want to join bacon, lettuce, and tomato together. In order to do that first, I need to use the string function around bacon to tell C++ how to do that. And lastly, on line 6, do not get confused by numbers having quotations around them. If it has quotes, that means it's a what? A string. Questions on anything on here? I got some questions about this slide this morning, so I'm going to go back over this one too. On lines 9 and 10, can anybody explain what we're doing on lines 9 and 10? Creating variables, exactly. This is how you create a variable. I keep forgetting the 11 and I don't change it. On line 9 and 10, we're creating variables, string variables. So that anytime we say, give me first name, it gives me Michael. Anytime I say give me last name, it gives me Jordan. On line 14, I'm saying, hey, join them together and store the result in this new variable called full name. Why? Why did I name it full name? Because it's a combination of the first name and the last name. And on line 15, I just say print out whatever full name has stored in it, which in this case is Michael Jordan with no space. But remember, when we're doing things with multiple strings, joining them together, we normally want to add spaces in between. In this case, we never told it to add a space, so there will be no space. Questions on that? You saying what? So yeah, you could add a space after the L. You could have added a space before the J. Or you could have just did plus a space plus last name. I prefer to see it plus space plus last name instead of trying to fix the name itself to include a space. Any other questions? Yeah. Good question. So he asked, why don't we put the quotations around first name? If I put quotes around anything, it becomes what? A string. So literally, once it sees the quotes right here, it'll be like, it's going to consider this a string with the value of first name instead of a variable. So I think I peeped that you did it on there. Once you create your variable, you do not put it in quotes. Otherwise, it's a string. It's just a string. I figured that was going to happen. I'm going to give y'all some grace. Any other questions on this slide? So substring. I think this one is a little difficult to wrap your head around, so we're going to keep practicing and practicing. Remember, substring on the inside, put two numbers in there. The first number in yellow is the position that you're starting at. So if I want some string from the very beginning, I would use a 0. Why? Because C++ starts from 0, not 1. If I would have put a 1 in that yellow place, it would have started from the second character, not the first. Then we know in the blue, the second number that goes in there, that's how many steps you want to take to start building this new string that gets returned. And remember, whatever position you start at, that is your first step. So if you put a 0 and another 0, you will get an empty string because you never took a step. You always must have a 1 or greater if you want some kind of result. And lastly, yeah, both of these can never be negative. You can never start from a negative position, and you can never take negative steps. So putting a negative, no, it does not walk backwards, if anybody thought that. Some use cases for it, boom. Line 5 and 6, I'm creating some variables. Line 5 is the string that we're going to actually operate on. Line 6 is where we're going to store the result. So going to line 8, remember, 1 means start from the second position because we start counting from 0. So if I have a 1 and a 2, and again, I advise you to kind of draw it out like this so you do not miscount. You know, if your finger's a little, you might slip, and now you kind of mess up the indices. So draw it out, and I say, boom, let's go to box 1. Box 1 is the E. And I say, all right, how many steps do I take? I have the 2, so I know I count this as the first step, this as the second step, and we done. That's it. C++ is going to take that and say, all right, what you want me to do with that? You said store it in this variable. So we're going to store the EL as a string in my variable. Does that make sense? We're going to keep doing the same thing. And remember, lines 9 through 11 is me just changing the value of this variable. I'm just changing the value. So first it equals EL. I go through the same process for line 9. It gets changed to O. Because I started from the 4th box and I said take 1 step. Likewise for line 10, I'm saying start at the 0 and take 10 steps. But remember though, if you put, let's say, 1,000,000 instead of 10, C++ knows to stop at the last character in the string and give you that. It's not going to try to take that 1,000,000 steps because it's smarter than that. So 0, 10 is going to give me the whole string. In that case, if you know you want everything from the string, you can just leave off the second number and close the parentheses. That'll give you everything in the string. Questions on that? Say that again. Yeah. So you can put 0 and put no second number, and that'll give you the entire string. I'll show you how to do that. I mean, you probably already know how to do that, but I'm going to show it on Edstone. Let's see. pointing your attention to the code, right? So going through the code, I started it off just like any other C++ program. And then on the inside, I do what? I create a variable called name. Its value is first space last. On line 7, I say, hey, print out this name, but take only a portion of it started from the beginning, and then I didn't specify a number to stop at, so it's going to give me everything. Does that make sense? So boom, on line 7, do you understand line 6? Yeah, that's just pretty good. Line 6 again is me creating the variable. The variable has, what's the name of this variable? What's the name of the variable on line 6? Name. The name of the variable is name. Anybody confused on why that's the name of the variable? Well, I think string, the first word, that's a data type. I'm saying why you say the name is the name of the variable. I'm saying if you by confused or why, how we got the name. So read it from left to right, right? We have the string, space name. That's the name of the variable. I named the variable name. Yep, so the thing that comes after the string is always going to be the name of the variable. I could have named it, yeah, I could have named it anything. It's defined by the user. So you could have named it anything. You could have named it X or C or Y. And then on line 7, I say, all right, give me this string. Started from the beginning, and then I didn't specify another number. Remember, 2 numbers normally go in. Starting position, and how many substitute. I never gave it a number for how many substitute. So it's going to be everything from that position. So if I would have put a 1 in there, it would have started from the second position, then everything after. Does that make sense? Any other questions on this? Remember, at is really similar, except only one number can go in there. When you call the at function, only one number goes in there. And that number is what index you want, or what position you want. So if I put a 0, it's going to give me the first character. If I put a 1, it's going to give me the second character. If in any event I put a number in there and it's not a valid number, like in my box or diagram, it's going to throw an error. If I put a negative number in there, an error. If I put a 1 million in there, unlike substring, I can figure it out. The at function cannot figure that out. You can't reconcile it. It's going to throw an error. And I feel like what you really want to do is take these slides, copy and paste them in the head stuff, play around with them line by line, and prove me wrong. Understand why some of this stuff is happening. I even uploaded a video on how to compile and run your code in the head stuff. So you have the tools you need to be able to test this on your own. Questions on this slide? You know they on edge stem, right? Like the video, YouTube. I can write it if I don't think I got no marker. No, I don't. I'll probably send out an announcement. Yep. It might not be anymore, but I got you though. As a lab tip, and this is gonna be the last slide, and then I'm gonna come to you. I think this is the last one. Second to last or third to last. Boom. Lab tips. You do not need to create your own variables with the names James Bond. All the examples you see with names, you are not creating those. All you have to ever use is the term or the keyword name. See how name is in like the code letters? That is what you're using. You're not creating those strings with the names in it. Those names have already been defined on my end. You do not need to use them. All you need to use is name. So when you call substring at with the cat name, you'll be using name. Name dot whatever. So if you have those names in your code, you want to start swapping them out for name. Showing you what you probably had at first. An example of what I was just explaining in the last slide is line 8, right? So this is kind of what you see in your lab, right? Void question something, question 0, question 6. You're going to see string name in here. This means I'm providing you with the name. You're not providing me with the name like on line 8. That's you creating a name and you're using that name. This lab is saying, nah, I'm going to give you the name and your code should still work for any name that I give you. So looking at your examples, if you say, all right, James Bond, it says take off the bond part, so you're counting the indices in James Bond. That's not going to work for every string. It only works for James Bond and strings of that length. So your code should be dynamic enough to work with any string I give you. So what you do want to do is something like this. Like I said, use name instead. So when I do the length, I don't calculate the length of just James Bond. I calculate the length of whatever name is. So name could be anything, but you want to calculate the length on name. Likewise with the substring. You're using name. You're not using your own created strings. Questions on that? Back? All right. Alright. That's it. I mean, I know we don't have that much time, but the last 20 so minutes is for y'all to work on homework, lab, ask questions, bounce questions around. And yeah. I stress y'all out enough today. Huh? Right. And this y'all homework. Make sure you get a picture for class. So if I'm not grading your work and I'm not responding to you, then what? You're gonna be like, right? He don't respond. He don't. Oh no, I don't be tripping.